All right, we have now moved to section 2, which covers questions 4 and 5. So let's take a look at where the scenario goes from now. It says, number 4, review transformation 1. Each point in the preimage is mapped to a point in the image. For this reason, the transformation can be expressed as a function. A. Complete the table to show the positions of the four corners of the rectangle when figure A is mapped onto figure B. And it gives us some points here. Okay. B says, for any given point, how does the transformation change the x coordinate and the y coordinate? C says, you can use the notation 1, 10, arrow 1, 4 to show how a point is transformed. When you use the notation to show how a general point xy is transformed, you are expressing the transformation as a function. Express transformation 1 as a function. And this arrow, when we read that, we should actually say 110 goes to 14. Okay. Then you will also be looking at question number 5. Question number 5 states, review transformation 2. Complete the table to show the position of the four corners from rectangle when figure B, now B was this second half right here, okay? So make sure you transfer those over. When B goes to C, then it says for any given point, how does the transformation change the x coordinate and y coordinate? And can transformation 2 also be expressed as a function? Explain why or why not, and then write the function if it exists. I don't think that these should take you rather long, so let's go ahead and we will take a 7-minute time for this and come back. Go ahead and pause your video, 7 minutes to complete questions 4 and 5. All right, as you can see, the answers to questions number 4 and 5 have been provided for us. Number 4, I went through and I listed those ordered pairs, and I actually went back to the previous page to find them. Okay. Then what I did from here is it says the x coordinate remained the same. I noticed that those stayed the same, but now I'm looking at my y. Y went from 10 to 4, 2 to negative 4, 10 to 4, 2 to negative 4. So that's actually a decrease of 6. So when we write this generalized formula or function, we say xy, which is any ordered pair in this transformation, goes to x, comma, y minus 6, because the x stays the same, the y decreases by 6. Let's take a look at question number 5 here. So I pulled these over from question 4, and then I went back and I looked at my picture back on the first page, and I said, well, then I had 1 negative 8, 6 8, and 6 negative 8. Now I look, what happens with my x values? Well, my x stays the same all the way across, right? However, my y went from 4 to 8, negative 4 to negative 8, 4 to 8, negative 4 to negative 8. That would be a multiplication of 2. Even though this is not rigid, because it doesn't preserve the size, it can still use a function because each point maps to a point on the other one by following a simple skill. The x's, you said, stayed the same, but my y's were multiplied by 2. So we would say xy goes to x, comma, 2y. On to your debriefing question.